Of today's lecture is twofold. First, to understand, being able to define what is cloud computing based on the data centers and services that we discussed yesterday. What are the cloud service models? What are the cloud deployment models? That would be the end of the first lecture, and then we move forward to understand what is the economics behind cloud computing, why cloud computing has become so popular, what is the main business driver, business model, what is the cost to performance model that actually drives organization and institution to use public cloud. So we'll try to understand that today. So in the first part of the lecture, we will try to define what is cloud computing. So when cloud computing evolved about 10, 12 years ago, and if you ask certain people, say what is cloud computing, they will come with different definition as you see on the screen. Someone will say it's widely distributed, it's network based, it's storage computation, it's everything as a service, it's platform as a service, it's software as a service, and then as you ask more and more people, it gets more and more confusing. So today's goal for us is to understand the basic definition of cloud computing that covers the features, all the features that can be used to define any public, private, or hybrid cloud. So just for example, just to give you a view into what people used to think 10 years ago, some people said cloud is business to business and cloud is grid made right. So all this definition that came up were not actually correct, because they're all just based on perception or lack of understanding of cloud computing. So there were also some serious definition. For example, this is one coming from University of Berkeley, which is one of the top research lab in the world, and they had semi-complete definition of cloud computing and defined this as to call anything as the cloud computing, it should have the following characteristics or features, which includes it should give users the illusion of infinite computing resources. For example, when you're using cloud services hosted data center, you should feel that you have unlimited or infinite amount of resources and services and it will never finish. It should give a user, it should free up the user from the upfront commitment. For example, you don't have to commit to anything, you just pay for the resources on the go. It is pay as you go. And it is driven by a certain business model, and the business model is anyone can use a cloud service as long as he or she has a credit card under pay as you go model without having to buy any hardware software resources. So this has a lot of parallels to, for example, how we use Uber today, or any taxi service that we use. That of course, if you want to go from point A to point B, you don't have to buy a taxi. You can just rent it for 1 hour or half an hour. The same philosophy was used to define and sell these cloud services from business perspective. So like that, there were many definitions, but out of those all definitions, similarly, if you go to Wikipedia, they will have one other definition that says that it is a cloud computing, the style of computing in which dynamically scalable and often virtualized resources are provided as a service over the internet. This definition, similar to others, are semi-complete. Right. So obviously there are so many definitions, and then none of them were complete. Then there's an organization in USA, it's called National Institute of Standards and Technology. So the goal of this organization is to actually define standards for computing and networking paradigm. So what they did, they combined all these definitions together, and they come up with what is something called a NIST definition of cloud computing, which is one of the most complete definition of cloud computing that defines these characteristics, service models, and deployment models. So if you can understand the NIST definition, you can pretty much understand what to call as a cloud and what not to call as a cloud. So that we'll be discussing next. So how NIST defined cloud computing is as a model for enabling ubiquitous, convenient, on-demand network access to shared pool of resources. And these resources could include networks, servers, storage, applications, and services that can be provisioned and released with minimal management effort of the service provider and service user. And this model included 5 essential characteristics that we go in detail of each of them, 3 service models and 4 deployment models. So this definition was the most comprehensive one that covered all the important features, service models and deployment models of cloud computing. So now going into the first keyword, convenient on-demand network access. So what that means is, if someone is offering cloud services inside a data center, you should be able to access those cloud services, hardware and software, from anywhere on the internet, from any country, any location. So the location of the users or the customer doesn't hinder its quality of service. That's one of the key characteristics for someone to be offering a cloud services like Amazon Web Services or Microsoft and Google. That it should be accessible from any point on the internet. The second important feature is the hardware and software resources and the storage services offered by the cloud computing provider should be configurable. So you should be able to configure your resource without being able to actually going inside the data center. So you should be able to configure the hardware, the software, the virtualization through programming APIs or through command line. So some of these things you are doing in your coursework, and as you go through those steps, you'll understand how do you configure a Docker cluster using command line and through the SDK. So you will get that experience in doing that coursework. The third keyword is rapidly provision. So what it means is, whenever user needs any hardware or software application, they are able to provision it based on few clicks on the browser. They don't have to buy a hardware, set it up, set up the networking, set up the operating system, everything. Everything is done for them. What they only need to do is just click, and the server and the hardware is ready for them to use. And all this then leads to, because it's rapidly provisioned and configurable, on the user side, there's a minimal management effort of the hardware and the software. So that's on the user side. But do you think it's the same for the provider of the cloud computing, that they also have no management overhead? So this minimal effort is on the user side. So I am a cloud user, I want to use Amazon. I don't have to care where the data center is, where is the rack server, where is the switches. I just click, they'll give me one server, and I can host my application there and do my work. That's from user perspective. But is it same for the provider perspective? You think for them it's automated, or there's a lot of work that goes behind the scene? Perhaps a lot of work. So they have a lot of system admins, network admins, power engineers setting it up, setting up the data centers, and then so that it makes it easier for you. So till now in our lecture, we reflected upon all the hardware side of cloud computing, that we have data centers inside, we have blade servers, storage and network. But just setting up the hardware, will it make these features available, like configurable and rapidly provisioned? Just setting up the hardware, will it make all this possible? Or there's something missing in between that is required to make all this possible? And if something is missing, what could be that? So you set up a data center with all the hardware, but now what NIST is saying, to be called as cloud computing, you have to support those features. And just putting up hardware in this room is not going to support those features. So what could be the missing link here is required to support the features that we are understanding as part of this definition? Like, how can we make the data center hardware rapidly provisioned? What could be that missing link? Yeah. So you need to write a lot of software. So pretty much you need to write a lot of management software. You need to install virtual machines, hypervisors, if you use hypervisor-based virtual machine, or you need to install containers if you use Docker-based. And then you need to write your data center orchestrator, which is also a software, so that it can manage your hardware software resources. So one of the key challenges to understanding cloud computing is just not about setting up the hardware infrastructure, but the key is to write the data center orchestrator that can manage those hardware resources and offers users these APIs over the internet, so that the features mentioned here could be easily provisioned and provided to the end user. So in the lectures from tomorrow, we will be focusing on how to write that software. What are the main elements of those software? That includes virtualization, orchestrator, monitoring, load balancing. So all those features we will study step by step. Right. So in terms of on-demand self-service, it draws parallel from supermarket that when you go, you buy something, instead of going to the checkout which is attended by a person, you just do your self-checkout. So as long as you have a credit card, you can buy something and check out that object. Similarly, in the cloud computing, as long as you have a credit card, you don't need to talk to anyone. You can just go buy as much service you want, as much storage you want. It's all self-service, all dependent on your usage pattern and depends on how many servers and storage you use. You will be charged automatically over every month based on the billing cycle. As I said before, broad network access, that basically means as long as you are connected to the internet, irrespective of your network media or your end point like mobile phone or laptop or desktop computer, you should be able to access those cloud services from anywhere, from any point of the network, from any device. So it doesn't matter whether you have a thin client or a thick client platform. And the third one is resource pooling. So to really make profit, or to really the main business model behind cloud computing is the resource pooling. So what this basically means is that I buy X numbers of servers and I share with large number of users, and I share with enough number of users that I make profit on that. So how can I do that? I can only do that if I share or sell my services, my cloud services, to multiple number of users. So the key concept behind enabling cloud computing is resource pooling. How they can take their physical pool of CPU, memory, network, and virtualize into virtual CPU, virtual memory, and virtual network, and then lease or allocate that to different users who want to use their cloud services. So this resource pooling and multi-tenancy is the key to enabling cloud computing, and a lot of algorithms go behind that, and a lot of software-based techniques are used to be able to enable this resource pooling between the users. And one of the key technologies is the virtualization, which we'll be discussing on Thursday lecture, how resource pooling is enabled through virtualization, which is based on hypervisors, or containers, which is based on Docker. So there are different ways to pool the resources, but provider use one of those mechanisms to pool their resources between the users. And obviously, how you pull your resources has major implication on performance, scalability, and the security that we reflected upon in this morning's guest lecture. So in cloud computing, can you know if you rent a virtual server from cloud computing? Can you know from where that virtual server is hosted, or are you interested to know that? Or you may be interested to know that, say, think about GDPR. You may be interested to know that, right? So for example, if you are, say, NHS Trust and you want to do some analytics over your patient's data, you are interested to know whether my virtual server is hosted in Europe or in UK or America. So it is important. So although for cloud provider, look, where they give you a virtual machine may not be that relevant, but from a user perspective, you have to make those decisions from which data center, from which cloud provider I'm going to lease the computing server, because that will also determine where my data is going to reside. And that has implication on DPAs and GDPR that affect data sharing, data processing constraints. One of the main driver behind the success of cloud computing has been rapid elasticity. So it's rapid elasticity means it's like rubber. You can scale your infrastructure from one server to 1,000 servers, bring it back to 50 servers, or again bring it back to 70 servers. So this is something which is only possible through cloud computing. It is not possible by a traditional resource management, traditional data center approach, because you can't really do that on a large scale. So this is why cloud computing has been very successful, as we see in the example for that gaming company Animoto that started with few number of VMs, and in few days they scaled to 5,000 virtual machines, and then they went back to 1,000. So this is one of the really cornerstone example for elasticity and how it is helping the startups and the companies who don't have money to spend in infrastructure to be able to host and offer the application services to the end users. Obviously, as I keep saying that a cloud computing, you have to pay for every virtual machine you use, every server you use, or every byte of data you store or transfer, and you are billed for that. Then, in order to give you accurate bills, one of the major requirement is that your cloud provider has to monitor your usage, how you're using the cloud services. So they always monitor for how many hours you're using a server, how much data you're storing, how much data you're processing, how much data you're transferring to the data center, how much data you're transferring outside data center. All this is billed on per message, per request basis, and at the end of the billing cycle, you're billed for all those activities. So if you want to deploy your application on a public cloud, you have to first do some benchmarking experiment and see, okay, how much data I'm going to transfer to and from the cloud provider, for how long I'm going to run the VM, and from that you have to do a calculation how much is going to cost me to run my application there. So in the next 20-30 minutes, we'll show you some equations that you can use to compute your cost of running application on the cloud. So that will lead us to economics of cloud computing. So as you see here, cloud has a technology focus that, okay, it is virtualization, it has data center, we run an application, but at the same time, you have to, there's economic angle as well. Things are not free. It's not free for use, right? You have to pay for whatever services, whatever data processing you do on the cloud. So every time you program your application on cloud infrastructure, you also have to take care of the economics behind it. How much is going to cost me over a period of 1 year, 2 year, 3 year? And if you're not careful, your bill could be as large as 1 million. And there has been instances, people who are using Amazon Web Services without considering the cost model had ended up with a lot of bills. So that's why understanding the economics of cloud computing is equally important than the technology side of it. Both goes on side by side. Just understanding one of them is not sufficient, as we'll see in the next lecture. Right. So these are the niche characteristics, and in the exam you might be asked this as a 5 marks or 10 marks question based on what are the niche characteristics, explain with example. So you can write the things written on the slide, or you can give the same examples that I try to give here. So this could be anyway, to help with the exam paper on the Blackboard. I have uploaded the exam papers from last 3 years. So that's a good tips to you guys. How do you go about it? And around Christmas break, I will also upload the answers to all those questions and the homework. So in the meantime, you should try and solve those questions yourself. And in my experience, people who have successfully solved the homework questions and then exam papers, they never faced a problem in this module, because that gives you a comprehensive pool of questions to practice and to exercise your knowledge. So I would highly encourage you to look into those as we go through the lectures. And around mid-Christmas, I will be uploading the answers to help you. This only applies to CSE 8110 student, not to the project student, because they don't have the exams. Right, so they were the characteristic of cloud computing, and now we have cloud service model. So how many of you know about these 3 service model? I think it has been around for 10 years, so you must have heard about that. At least people coming from industry must have heard about the cloud service model, because it's been almost 10-12 years that this thing has come up. So So the cloud computing broadly has 3 service models. So the first one is software as a service, second one is platform as a service, and third one is infrastructure as a service. So starting with the most simpler one, software as a service. Can one of you give an example of software service that you're using every day? Maybe you're using right now as well. Gmail, very good. Facebook, Twitter, Instagram, and the list goes on and on. So that's the software as a service. So will you say that when you're using software as a service, are you doing cloud computing? You're not doing any. You're using it, and maybe Gmail is doing computing on your behalf. So based on whatever request you assign to Gmail, it has some virtual machines where it is fetching your email or sending emails or searching your emails. So you are actually not doing cloud computing, but you're making someone else do cloud computing. Like whenever you post a picture on Facebook, you share with your friends, you are making Facebook do a lot of work. For example, one of my friends in Facebook say that for every Facebook message post that you create, it creates 80 more messages inside the data center. All your posts, the way they distribute your post between your friends, they put copy in the database, they tag your photo, compress it. So every request you do on the Facebook creates 80 network traffic message on the network. So you are actually not doing cloud computing, but you're actually making someone do quite a bit of cloud computing, and that is done by this provider. So why do you think this Facebook and Gmail are doing this cloud computing for free for you? Because this service is free. So, not so much selling your data. I mean, Facebook is in trouble for that, but what is the other business model they have? Why they are doing advertising, right? So they always do based on your profile, your age, your interest. They always throw up a nice advertising on you, and based on that, they charge that company, right? So there is a different kind of business model, but which is very important. And we actually don't realize it, but that's how it is. We are making them do a lot of computing, but they're making a lot of money by showing us those advertisements, right? But anyway, if you are a software as a service user, it's not much of work. I don't think you don't need to take this module to be a software as a service user, right? Then the complexity increases as we go down the service model. So for example, moving on as a cloud platform as a service. So have anyone of you ever worked with platform as a service in your past job? So what exactly did you do in as a platform?
For the previous model, we used OpenShift.
Sorry?
We used OpenShift.
Red Hat. Right. So what happens with platform as a service is these cloud providers like Microsoft Azure or Amazon, they give you ready to use software images that you can actually use to create bigger application. For example, they can give you ready to use database image, ready to use web server image, ready to use load balancer that you can fuse together, compile together to create a 3-tier web application. So based on which cloud provider you interact, there will be different complexity. For example, say going back to our coursework. So you think on your coursework you are doing, you're working at which layer? Infrastructure or the platform? Or both, right? You're working on both. So you have the web container, the CI advisor, the load balancer, and all those things. So those are the pre-built images which is available from Docker Hub. So those things can be classified as the platform as a service. So you can use those things to create your web application. But at the same time, you are going to deploy those containers on your laptop on the Amazon cloud. So you are then moving from platform as a service to infrastructure as a service. So you are actually working at both the layers. And as you see, as compared to platform as a service, working at the infrastructure is much harder. And it again depends on which provider you're working on. So for example, if you use the managed platform as a service that offered by Amazon and say Microsoft, then you don't have to care about where your components are running, on which virtual machine, where your data is stored, because they'll manage it for you. But however, you are a big enterprise, you want to optimize all your builds, then you actually care about the hardware configuration on which you are going to run your databases and the web application and the storage server. Then what happens in that case, then you have to come down and work at the level of cloud infrastructure as a service, where you have to really understand what kind of hardware configuration you need in your virtual servers to be able to successfully deliver your web application, your database application, your load balancer. So that becomes more complicated. We will go more in detail in lecture 3 or 4, but as you go down this track, the complexity of interacting with the cloud as well as complexity of programming these services becomes more and more complex. So as we discussed, if you are at a software as a service, it's much simpler. You just do a click and the cloud provider does all the work for you. If you are platform as a service, it's a little bit harder than the software as a service, but still, if they are managed platform as a service, then you just select your images, select a data center location, and everything deployed. But if you work as the infrastructure as a service, then you have to do all the work on, okay, which kind of CPU, which kind of memory, which kind of network you need, what IP address you need, which data center you're going to host your services. All these decisions have to be made by you. And on the right hand side, you see there are so many providers. If you search right now in the cloud domain, there are more than 1,000 providers, even more. It keeps growing, and they are being added at different layers of service models, either infrastructure, platform as a service, software as a service. So anyway, as you see from this, most of the jobs in cloud computing discipline is around infrastructure as a service, where you actually become a data center manager, data center administrator, and you offer those services to the user. And also a lot of jobs on the platform as a service, where you become cloud application engineer and cloud application integrator or consultant or business analyst, where you understand the specification of application, you have the knowledge to transfer that specification to a cloud deployment and manage the life cycle. So a lot of companies are now going through that approach, that they have something running in-house, but they need new engineers to migrate those applications to the public cloud, or maybe in combination of private and public cloud. So in that case, you need to have knowledge of the full stack, and so that you are able to work on such projects and get those jobs. So of course, we'll go in all detail how to program a platform as a service cloud abstraction as compared to infrastructure as a service abstraction. So will be a big focus of lecture 3 and 4. We'll go in detail of that. So for now, this is sufficient. So like I said, our Outlook email is a software as a service that all of us use all the time. I send you all those emails. Right, so how many of you heard about this deployment models? Private cloud, public cloud, and the hybrid cloud? I always keep getting one hand, maybe two hands. Right, two hands. Right. Okay, so some of this I have already discussed. Let's go in more detail. So according to NIST, we have 3 main deployment models for your cloud application. First one is private cloud. For example, our department, School of Computing, has private cloud in this building. And what I mean by that, they have few server racks on which they have installed some virtualization engine, and on those virtualization engine, they offer you the services like Nest, Blackboard, and other services. And access to those services within this building is only available to staff and students of this department, this school. That's why it's called private cloud, because access is restricted to set of people who have good security credentials, and we don't have to worry that you guys are going to attack our service. So it's not, okay, it's highly secure, it's on-demand service, but it's only available to group of users, like one organization or one department. Similarly, we can have a private cloud on the level of Newcastle University as well, and the access to those is only provided to Newcastle University staff and the students. So that's one simple abstraction, but the actual business model behind the cloud computing is about public cloud and the hybrid cloud. That's where all the application engineering and application migration is happening. So for example, I keep talking about Amazon Web Services and Microsoft Azure. So they are the example of public cloud. So they are the one who build up this massive data centers all across the world, set up the server racks and the virtualization, and they offer lease those services to you under pay-as-you-go model. So when you deploy your application on Amazon Cloud or the Google Cloud, you're actually doing public cloud computing. One of the slides says that public cloud is less secure. So we had a security lecture this morning. So from using that knowledge, why I wrote that public cloud is less secure than private cloud. I wrote private cloud is highly secure. What could be reason for that? So in relative to private cloud, public cloud is less secure. Why would be that? So more users, more unknown users. For example, if you're storing your data or computation on Amazon Cloud on certain VM, there could be some other VM on the same rack from some unknown users that you don't trust or your company doesn't trust. So that increases your risk. And similarly, your virtual machine or your virtual server can be mixed up with many other virtual servers from many other people from different parts of the country that you don't know about, and it increases your risk. So you have more attack surface on your virtual machine when you run the same thing in the cloud as compared to the private cloud as compared to public cloud. That's why it becomes less secure. And obviously, both public and private cloud, they have to offer all the NIST characteristics that we discussed. So all those features are supported, but how they differ is in terms of security, and elasticity. So in between private and public cloud, which you think will be more scalable?
Public one.
Public one, right? Because it's a big enterprise. As we said, for Google, they have 650,000 blade servers in a data center. I think if university wants to make that big data center, we have to sell off the whole university to actually build a data center. It costs like few billions. So they always be more. So if you want an application that want rapid elasticity and auto scaling, then of course public cloud is more stable for your needs. Then coming back to hybrid cloud, which is the combination of the both that inherits the best of the both worlds. So let's go in detail for the hybrid cloud. Right, so I got one statistics on how people are using public and private cloud.